Welcome friends, welcome back to our channel Crystal Learning. So today we will see a concept which depends upon the subject mechanical vibration and strength of materials. So these two subjects, concept of these two subjects are involved in solving this question for a better understanding. So this question says under repeated loading a material has stress strain curve in the figure below. Which following statement is true? So this is the figure. The smaller the shaded area, better the material damping. Larger the shaded area, better the material damping. Material damping is an independent material property and does not depend on this curve. This question came in GATE Mechanical 1999. So here stress strain curve falls in strength of material chapter, and this material damping concept comes in mechanical vibration. So both of these two subjects will be involved in solving or explaining the concept for solving this question. So let's see the theory. Steric damping. So what is steric damping? The stress strain relation of a material under cyclic loading at a point in a vibrating continuum possesses hysteresis law such as shown in figure. Therefore, we see when a material is vibrating, so the stress strain cyclic curve generate like this. Okay. So it is getting strain, then a cyclic loading is there. So this is complete cycle, and this area under this curve or under this cyclic load will denote the damping capacity per unit volume. In this axis we get load or stress, in this axis deformation or strain. So the area of this hysteresis loop gives energy dissipated per unit volume of material per cycle, and this term per unit volume is damping capacity. So damping capacity is this energy dissipated per unit volume, and it is denoted by D equal to cyclic integral sigma df. Okay, so in this case of cyclic integral, force with respect to displacement, which is area of the hysteresis loop, is equal to work done against damping force. So, or we can see that it follows that this loop area is the energy dissipated per cycle of the motion. So, when material is vibrating, so damping is denoted by what amount of energy is dissipated. If more energy is dissipated, then it is having better damping capacity to reduce the effect of vibration. This damping capacity, which when divided by material volume, gives per unit volume damping capacity as before. So we have seen what is damping capacity, why it is needed. So if you talk about damping capacity, that indirectly means energy dissipated per cycle of the motion. So from the figure it is known that it is quite obvious that larger the area of hysteresis loop, if this area is quite large, large will be like this. Okay. So if this is large, then higher plastic strain level of the material. So this plastic strain material will increase. Okay, plastic strain material will increase, and larger dissipated energy or damping means this area will increase, then damping capacity will also increase. Okay. From this area you can get this. Okay. So more energy will be dissipated. So by understanding the concept of damping and dissipated energy and this hysteresis loop, you can do this question. Okay. So now we get that option B is right. The larger the shaded area, better will be material damping. Damping capacity will be more. We have seen damping capacity will be more depending upon that area. So B option is right. So you might say that why we should study further, because for the same question other things can be framed. So now the question comes in mind that what is this type of behavior of stress strain curve. For that we have to study the concept of strength of material. So let's study. So if we talk about elastic plastic material, what are elastic plastic material? elastic plastic material where the stresses cannot raise above this elastic stress. Okay, but strain gets accumulated. So it is known as no hardening, no softening in the material. That is known as elastic plastic material. This red one is strain hardening material. Means for further straining the material, you have to increase stress. And this is strain softening material. This green one, this means for further staining the material, the stress value is decreasing. So these are the three types of material. For these three types of material, this hysteresis loop is developed. So this first graph is for elastic plastic. Okay, EPP, elastic perfectly plastic material. So you see the hysteresis loop. Okay. This will be the shape of the hysteresis loop. So next two will be, first A is kinematically hardened material, okay, or stain hardened material. Shape will be like this. And for kinematically softening material, shape will be like this, or stain softened material. So if I frame the question, this hysteresis loop or stain diagram is for stain hardened material, elastic plastic material, or stain softened material. So it will be stain softened material which was asked in the question. So this way question can be framed. So we have seen that what type of question can be from this graph. I hope you enjoyed this lecture and the concept about hysteresis loop, material damping, little bit concept because we haven't studied the theory. Here I assume that the repeaters or who have studied the theory, they are getting a better understanding, and the new students who haven't studied the concept, they are getting some idea that how this question has to be approached. So when they will be studying this mechanical vibration or strength of material, this question will be remain in their mind, and there it will become much more clear. So we will meet in the next lecture with the next question. Till then, have a nice day.